Today we'll talk about building the custom AMI. So when we say AMI, in AWS world we call it as AMI. In other word, they call it as machine image. You can call it in multiple terms. So ideally what it means is when we create a server, when we create a instance, then we provide a base from where it should start or from where it should begin. So for example, if you want to launch an instance in the AWS, you would have seen launch instance, and one of the parameter would be like what the application and images. That's what the AMI translates to. So you can use Amazon Linux, Mac OS, Ubuntu, and various packages available. And it also has some options where while booting you can provide a specific command which is called it as user data. That's where like when you want to start a server, right? For example, this consists of Nginx in it, and you want to boot the instance up. So those kind of prerequisite command you would be passing it as an user data. But if you ask me, does this base image consist of all the software required? For example, Nginx for an instance, it won't have by default. What AWS offers is the plain image or plain OS. It might have some basic things like, for example, if you go with Amazon Linux, it can consist of like AWS CLI and other native tooling, but not occurs of your own custom need, right? So in that case, if you're going with the user data mechanism, like each time booting it, you are installing your custom software package, then it's going to delay the launch instance time because it needs to fetch the software, download all the package, install it in your machine, get things ready, and then only the instance can completely boot up. To avoid this delay, what people generally go is they go with pre-baked AMI. When you are creating the image or when you are launching the image, then it's just going to have the software pre-installed. So once the base image is created and you keep it, then people can refer it and a number of instances can be created from there. So there are like various names in industry. If you call it as golden AMI, if you call it as standardized AMI, there are various people call it in different way. The main purpose it solves is one in terms of what software it goes in. It has pre-baked so that whenever you are creating, you don't need to wait for the entire software to get installed. Same way, the other benefit you get is like you can standardize the application team. For example, you want to go with Node.js X version or .NET X version should be used by the team across. Then in the AMI itself, you can have it pre-installed so that people go with the specific standardized version. This also ensures you can standardize like the latest image is patched and no one is using the legacy. So you can have some rules to restrict people launching instance from the non-approved AMIs. So there are like a number of ways you can do it. So AWS also offers a custom softwares like where you can create your custom AMI. But then if your service is in like multi-cloud, then if you want to go with, then going with AWS native solution can be like a bit tricky. So that's where the HashiCorp comes with a solution called Packer, which is to build the custom AMI your own need, but not limiting to the specific cloud provider like AWS. You can have the same template across Amazon, Azure, even Docker images you can build it out of it. So you can go to this page, you can download the Packer based on your OS need. They also offers you the guides like how to start with and building the images. So in case if you want to start building on AWS, you can start with like Packer AWS and it's going to take you over there. So you have tutorials which is handy available to explore more on that. So today we'll see like a quick demo like how to start with and how to fetch the values required for those parameters and how to execute and build a custom AMI. So that we will see it as a demo. To begin with, the Packer can be written in two ways. One as a JSON file, the another one as the HCL language itself. So I generally prefer going with the HCL because in JSON you have some limitations like adding commands and as part of the document, whereas in a .HCL file you can add comments and make it more understandable way. Quite easy. Like if you're already familiar in Terraform, then it follows a similar syntax here as well. So if you see the file name, so generally the Packer, whatever you write as the code, it's going to be written in terms of the file name called .HCL. So you can have any name. For example, like given here as demo. So it should be like demo like followed by any name followed by pkr.hcl. So that should be your syntax name, the file extension for the Packer file. And for any provider where you are going to launch your custom AMI or custom image, it generally comes with three blocks. One is Packer, then the source, followed by the build. So Packer, you are going to set the plugins. So plugins as in like what provider it should get communicated, right? So in our case, we are going with Amazon. In case if you are going to communicate with Azure, then there is a specific plugin for Azure, like for GCP and many more. So where you can find the documentation of this, right? So if you go for same Packer and if you search with AWS, you are going to have the tutorials, that's for sure. But then let's see Packer AWS doc. So then you have the specific documentation itself for the Amazon specific. They give you the clear instruction like how your package, like the Packer block should look like and how do you refer this, right? And the version syntax remains same as of like how you use it in the Terraform. So if you give in as the tilt and greater than 1, so any minor versions are like it's going to get updated. So if you're giving like 1.0, then 1.1, 1.2, those things would get updated. So already made a separate video on the Terraform part. You can share it out like how it would look like, how the version handling would look like. So if you see Amazon EBS has this part, so that's going to be your source block, and each and every parameter they would expect, it's been there, and also like what is the value they would expect. So each and every part is being given as part of documentation, and when you start working on it, you can go and refer it out. And also if already an existing AMI is there and you want to fetch it out and refer it, same as of Terraform, you can refer the data source block, and then you can get the value out of it, like what is the AMI ID exist. I'm not going much detail into these parts, but let's see, this would act as a map for you to self navigate like how to go and fetch that part. Now if you go for the file itself, the one is the provider part which I have mentioned, and then the source block. Here we are going to use Amazon as the reference to create a custom AMI for the Amazon instance. And then we also have the build block. So in the source, you are going to define about the definition of the AMI, which should act as a base template. So you can give the AMI name. So AMI name should be like you can keep anything. So what name it should be named of the new AMI we are going to create. So let's say I can keep it as was and test, and you can keep like what instance type and region. And so this would be the main part you would need to focus on. So what would be the SH username when the instance is launched using the custom AMI you built it out, and this would be the filters of the existing source. So for example, let's say I can go through, let's try to execute it, and then I can walk you through like how it would look like. In the build one, you are going to give the name of what new AMI. So this would be the existing one, sorry for that, and then this would be the build one would be the new AMI which would be naming it out, and the sources like what it should act on. So that's why you're referring the source dot Amazon EBS Ubuntu. So basically you're saying that whatever the command you want to run for this one. As I was saying, like you can install custom softwares like for example Nginx, or run some default commands when you are pre-baking your AMI. All those commands would go here. So it can be a patch command, it can be installing your Nginx, it can be installing your database as part of the AMI. Whatever you would need, it would go as part of the command within the inline part. Okay, so the commands which generally comes for Packer is the first command would be Packer. So this is going to see what are the plugins it would require, and it would download it locally or wherever you are executing it. Then there can be the question asked like how it can communicate to the AWS, because we are not passing any credentials. The same standard process would follow here as well, which is either you can set the credentials as a terminal, or if you are running the Packer in terms of any of the EC2 instance, then you can give the permission as a role to the EC2 instance and execute it. So it depends on it, but you would never hard code your credentials as part of the code itself. So in my case, let's go to the account. So let me copy the access key. Anyway, just short-lived credential. So even if you screenshot it and try it after 15 minutes, it won't work. So now I exported my local credential, and then if you see here, we are looking for the US West 2 region, right? So always ensure that your credentials is configured to the specific region. In our case, it would be like I already kept it US West 2. In case if you're looking for something different, then change it. So in case if you're building AMI in EU West 1, then your region should be EU West 1. And so then you can also format it. You can also validate it, your code. So you can do validate. It's going to validate it whether the configuration is valid. Then you can create an image using a build command. So if I go for it would be under the images category. Then you see I already created one called Linux AWS. So this is going to come from here, right? So let's name it as something like, I can come to the question part Asma at the end of the session if all right. So what we are going to do now is we need to build it out, right? To the custom one to build it. So what we'll do is you use Packer build followed by the file name in it. So now what is going to happen is it's going to filter our existing image, and you could see it could find the image ID as this. So now let's see like how the filtering works. Okay, so I copied the image, so it should be the public image which you are filtering it out. And if I go with the AMI ID, you can see the AMI ID here, right? And so this is going to be the source part. So the actual image looks like this, and the AMI name you can see this one. So here we are filtering it based on the AMI name, which is Ubuntu images HVM SSD blah blah blah. So which exactly we are doing it here. If you see in the code, we are saying filters, the image name is this. So if I keep it in side by side, you can see they're using a wildcard. Star is the wildcard, and then we say it should follow this specific one, and that's why we're using the wildcard. So you can use wildcard to filter the name of the image. Then you can ask me like how can I get the value of root device and which virtualization type. So If you go to the AMI name in the console, if you scroll down, you can see details like the virtualization type, which is HVM, and what else we have seen, the root device type, which is EBS. So all the details would be available in the AWS console. In our case, AWS is an example which you can fetch out of it. And also you also need to focus on is the owner account ID. So for this specific AMI, this AWS account is the owner. So don't get confused. So actually our account ID is completely different. 85 something is that, right? But then the AMI account ID, the owner of the AMI is some other account. So in the parameter, when you pass it should be ensure that you pass the specific account of the AMI and not your, it would fail. Okay, so then that's all you would mostly do in any of it. So same way, if you want to do the same thing for, let's say, Azure, I don't have the Azure account, but I can show you like how it would look or the provider would look. So same thing, I Google Packer Azure doc, and same as of AWS, you get the similar page. So that's the beauty of Packer or any Terraform product. Like you learn for one thing, then you can just reuse the same knowledge what you learned in any other parameter. So they follow the same pattern. This is something for people who wants to learn Terraform or Packer. Like don't try to say like I want to learn Terraform in Azure or I want to learn Terraform in AWS specific. Learn Terraform and try to adapt in your own cloud provider. So instead of AWS plugin, you can use Azure plugin, and the commands remain same, and you would see the different part, like the source would be something close enough, and you also have the tutorial library, right? So if you go with, let's say, so everything is available. So if you know the concept of it, then you can get like what source would need and what parameters they would ask for. So for example, for Azure, you're going to use something like Azure, and you can go through the documentation, whatever we did for the same process, you're going to follow it, and the custom images, like the documentation is available, only 3 commands we're going to use it. So our image is still building up, and if you see our image got built up, and if we go to our console of AWS, and so currently we are in public image, you can switch to owned by me, which would be like you created it, and you see the custom. So you can build your own AMI. So generally as a beginner, what they do is that, at least how I did before introduction of Packer, is I used to launch the EC2 instance and then do whatever command I want to run it, I run it, and then I take build the custom AMI from the instance. So for example, I think I terminated it, but then there used to be an option called actions. Somewhere it used to be image and templates. So here you see like when an image is like instance is running, this action would be enabled, like create image. That also will create an AMI for you, but then it's more of manual action, plus you can't widen it across multiple cloud provider. Whereas this way you can code it, you can share it with your friends so that they can also try to run and do it on their own. So this is how the doing it as of code approach comes in. So in tomorrow's scenario, like if your company is like want to add one more software, you can just go to the repository, add one more line, and you are done. You don't need to worry about dependency and other extra factor required. And if you find a bug in the source AMI, you want to change it, you just change the filtering option and change to some other option, right? So this is more of tooling which comes handy to build your custom AMI. You see 1 hour session, you can add it in your resume that you know Packer. So that's how the DevOps tooling and the cloud technology works. So this covers the basic part. More advanced you get, you would variabilize it more, but I believe like as a beginner level, this would act as an example. Try to play with it. Any doubts?